In a previous video, I showed how to use a spreadsheet to be able to take data and plot it with a formula. I find the references or the formulas in spreadsheets a little bit tedious because of all the cell references. It doesn't really look like a mathematical formula we're used to. So I wanted to illustrate how we can use a program that I wrote. I call it Data Explorer. Uses JavaScript to be able to do formulas, but it does it in a way that we're able to type a formula using regular math. So if you haven't watched that other video, to bring you up to speed, what I did is I have this pattern in Google Trends that shows how the search for recipe in the United States for the last 7 days has a pattern that looks fairly periodic, and I want to plot that with a sine or cosine function and compare it, see how closely it follows a really smooth periodic function like sine and cosine. So what I'm going to do is from Google I'm going to export this as a comma separated value file, CSV file, that can be loaded into a spreadsheet. So I'll just download that. So we'll wait just a second for that to download. And when I open this, it's going to open it into a spreadsheet program. So we'll let it go. Wait just a minute for it to open up. So I have it set for Open Office, but this is a CSV file, so it's separated by a comma, and we can see that down here I've got the time when it's recorded and the rate of searching. I'm not really sure what units those are, but we want to import that, so we have our data. And let's see what we've got. Okay, so in my other video I showed how we could actually do formulas within a spreadsheet, but what I want to do is I want to actually do this in another program that I've written that I think is a little bit easier to work with. So the only reason I really open this in a spreadsheet is so I can have my data, and I'm going to copy that information and I'm going to put that back into my other program. So this is the website for my application. It can run in any browser. It can even run in a tablet or probably in a smartphone. But what we're going to do is we're going to create a variable by pasting it into a table. So we're going to paste those results, and notice I did include the name at the front. That's going to be a variable recipe, and so we'll create that. And it doesn't look like it did anything, but I actually have now in a table the recipe, and so here are all my values. And it's just like in a spreadsheet, I've got these in rows, but I'm not going to refer to these by letters. I actually get to use my variable name. Well, I want to add a new column for my time in hours. So let's go back and we're going to define a new variable. This is actually an arithmetic sequence. I am going to call this variable my time, and it starts, let's see, where does it start? See, this is universal time. I was hoping it had recorded in Eastern Standard Time. I believe that 3 o'clock UTC Eastern is 5 hours off. So this is 10 or 11 o'clock. We're in daylight saving time, so don't really know. Don't have time to think through it, but I think it starts at -1, and we're going to increment by 1 hour. And how much data do we have? Let's see, we have, let's go back to the data. I've got 168 different hours. So unfortunately, we lost what we just did. So we'll have our time, starts at -1, counts by 1, and we have 168. different data entries. So now we create our data, and now we can see that I've got time and recipe. We can look at a graph. By default, it puts the first column on the x-axis and the second column on the y-axis. We can change that so it looks like what we want, time and recipe. So here we have our data that we were looking at. I don't have a good way of connecting these points in this program yet, but it is what it is. Let's go back and let's look for the basic features. We're interested in doing this with periodic functions, so we want to find out where the maxima, the minima are occurring. So I'm going to just bring up a little note card for me to take notes on. We're looking for a maximum, so let's find, here we are right here. There's a maximum at 65 at time 18. So maximum of 65 at time 18. And where does it repeat? The next maximum, here it is at time 42. Then it's at 62 at time 42. Now, this is noisy data. It's actually changing in time. So we're going to assume that our maximum is something like 65 or 62. Let's pick a maximum of 63. Let's find the minimum. 21 is the minimum there. 23 is the minimum there. Let's say that our minimum is maybe 21. And we can calculate our period by how long it takes between 42 and 18. So our period looks like it's about 42 minus 18 is 24. That makes sense, because that's how many hours are in a day. So it's actually a daily cycle. So let's see, from our maximum and our minimum, we can find our center line. It's the average. So 63 and 21, the average of that happens to be 42. The amplitude, that's how far it goes from the center to the maximum. It's actually 21. It's a coincidence that that number showed up twice. And let's see, where does the maximum occur? The maximum at time 18. And that's all we need to be able to come up with our formula. All right, so I'm going to reference that when I go create a new formula. So let's keep that in mind. Okay, so we're going to define a new column for our prediction. So create a new variable. This is a dependent variable because it's based on a formula. We'll call it our prediction. And our prediction is, let's have that data here. We're going to use our center line, 42, plus our period, times, because we know where the maximum is, we use our cosine. Now we get to type our formula, 2 times pi divided by the period, times, and now in parentheses, our variable time, which we didn't give it a letter, we gave it an actual name, time, minus the time of the maximum, which was 18. Let's see, minus 18. Close the grouping, close the cosine, and we create our variable. And now if I go, I have a new column that's predicting my value from my variable. And I didn't have to do any copying, I didn't have to do any pasting. If I want to see my formula, I can go back, select my prediction, and I can go through. If I made a mistake, I can edit my formula and it'll fix it. So now we can do a graph. On our x-axis we want time. There's our prediction, nice periodic function. And we're going to plot it the prediction and the recipe, and I do that on my Mac by holding the Command key and clicking. I think it's Control key on a Windows machine. Control click. So now I'm plotting both the recipe and the prediction. Looks like it's overlapping this. I can change my minimum on my window. See X min, X max, Y min. The 20 is my Y min. Let's change that to 0. There we go. And we can see how it compares. So it's doing pretty well for several of the days, but our weekend, this would be Saturday and Sunday, there's a bit of a discrepancy. But we can see how it compares. I'll probably at some point go back and modify this application so that it can connect the dots. I just haven't done that yet. But we can see that our formula captures a lot of the dynamics of the pattern for lookups for the word recipe on Google.